Hi, I'm Mark. I'm the National Technology Officer for the ABF, and this video is going to talk about the technology we're using. So this is the third part of a three-part series of videos. The first one was a demo to show you what the system is going to look like. Second part was around the project and how we're approaching this in terms of cost and risk and so on, and this one is about the technology. I'll try and keep it as non-technical as possible, try and explain it simply to you. And if you have any more questions or want to get into any more detail or anything, just let me know. Thanks. So let's get started. So in this, there's some general stuff and some specific stuff. I tried to keep them apart, but it didn't really work. So it may go backwards and forwards a bit as we're going through. Hopefully by the end it'll all sort of come together to make some sense. So first thing is that we're building a web-based system, as you would have seen in the demo. Now, web-based systems are really all that are being built now. It's very rare for people to be building much in the way of desktop systems, with a few exceptions. And we need this to get out to as many people as possible, and we need real-time data and so on. So the web seems to be the best way for us to do that. I know some people are concerned that their internet's not very good, and will they be able to use it? You can use all of this system with a relatively poor internet connection. You may not want to do the club scoring for it though. So if you have bad internet, have a think about whether you want to stick with some of the excellent existing scoring packages that are out there, and you can upload the results to our system afterwards. It's also built so that it will run on a mobile device. We're not intending at this stage to build a mobile application. We're just intending to use the web features to allow you to view it on a mobile phone. You'll have seen, if you looked at the demo on a mobile device, that some bits of it are not very good. That's not a failing with the technology. That's just that we've rushed the code together a bit, and it needs a bit of proper work to get it going. The only bit that won't be web-based is, in order to talk to the BridgeMates, you have to run some software on the PC that's got the BridgeMate controller on it. So that piece will be a piece of installed software. But the rest of it, we're intending to be entirely web-based. We're going to build an API. Now, what on earth is an API? Well, an API is an application programming interface. So what this is a way for computers to talk to other computers. So normally when you're using a system such as ours, you use a mouse and a keyboard and you have a screen, and it's a human being that's interacting and driving the discussion and making things happen. That's not always the way you want to do it. Sometimes you want another computer to talk to your computer to be able to do things. And one of the reasons we want to build this is that the current systems are very innovative. The people that support them are able to make changes very rapidly and very easily. And this system, because it's going to be a bigger system used across the whole country, will by its very nature have to be more thoroughly tested and more slow to make changes. So what do we do to get around that? Well, we can still allow innovation by having an API, which means people can connect into the services we're providing, but do some funkier things in Excel or wherever they want to do that. So we'll make sure that's still in place. The API also helps us with testing, which will be quite valuable. Licensing. So we're going to license this with an open source license. So what that means is basically it's a free system. Anyone can access it, anyone can use it. Now, one thing to think about carefully here is that really there's no money to be made out of Bridge software. Nobody's making a living out of writing software for Bridge. It's very difficult. So giving the software away may seem unintuitive, but actually there's some huge benefits to us. So firstly, there's no money to be made anyway. We can't sell it. Secondly, it's not really giving anything away. It's the equivalent of a chef giving away a recipe. It's not free food. It's just a recipe. You've still got to go and use that to make your own system and to do everything you want. Now, the advantage of open source licensing is that if anybody takes that recipe, so our code in this case, and they use it in something else, so they take it and they make a pasta bake with our bolognese sauce, that's also got to be open source. So we get access to any derivative works, anything that they've done using our product. Also, if they found a new ingredient that made the sauce taste better, they've got to tell us what it is. And we can decide whether we want to put that in our version of the recipe or not. So open source, you'll be hearing a bit through this presentation. We're not the only people doing open source. Pretty much everything that we're recommending to use on this will be open source as well. Let's have a look at the technology stack. So this is the different bits that we're going to put in place. So let's throw up 3 boxes along the bottom, and this one on the right, that can be the client side. So that's what's running in your web browser. So when you click on a link, we send code to your web browser, and that renders the screen that you see, and also has some other code that runs in there to do some interactive stuff. Where that code comes from is the server side. So that's where the core bit of our system is going to run, is on a server in the web, and it sends the code to the client for your web browser to show you. The last box is the database, and that's where we store our data. So let's start throwing some things out there on each of these platforms. So let's start with the client side. We'll put 2 things up there, and I'll come back and explain what these are later. But we're going to put 2 products there from Facebook, which help us with managing things on the client side. We're going to put a programming language out there, and you get some nice funky names with all this technology stuff, so you see a few rather oddly named things. So Python's the language we're going to use, and I'll talk in a minute about why that is. Django we'll throw on there as well, and Django REST framework. Again, I'll come back and explain what these are, so don't worry about them at the moment. And let's be more specific with the database. We're going to use Postgres. So let's start by going through these different components and see what they all do. The first one's Python, so that's a programming language. So if you have a look at the most popular programming languages at the moment, these are the top 10. You can get varying lists. This one is one where they take a combination of things. How many jobs are available, how many support tickets are raised for the languages, how much discussion is there on forums and things, and they come up with an aggregated view of what the most popular languages are. So here we can see all these languages. Now C and C++ are just not suitable for what we're doing, so we can get rid of them straight away. They're not appropriate for building web applications. Down the bottom there, second from the bottom, Objective-C, that's Apple's programming language for Macs, so not appropriate for what we're doing here either, so we'll get rid of that. And up the top, Java it can be used for this sort of stuff. It tends to be used for some legacy web applications, but it's not commonly used, and you wouldn't find very many people writing an application from scratch to do what we're trying to do in Java. So I'm going to take that one off as well. Now, I have a personal loathing of PHP, so I'm going to take that one off. It's a pretty horrible language, and I personally don't like it. So that's gone. So what are we left with? We're left with, let's take one more off actually. VB.NET is Microsoft's old programming language, which has pretty much been replaced by C#. So you wouldn't write something in VB.NET, you would choose C#. So now we're down to, what's that leave us with? 4 choices. And you can see that Python is of those 4 choices the top one. So not only that, it's not only got 10% of this list, but it's also growing. So that was a change in the last year. So it's actually probably one of the core languages. The other one, JavaScript, we have to use anyway. So JavaScript is what you use in your web browser. You can also use JavaScript on the server. They call it typically it's Node.js. And that would also be a very good choice, but none of these are bad choices. C# is Microsoft's language, which is a proprietary language, and we've pretty much picked open source for everything else. So I think the choice of Python is reasonable. The extra thing that tips me towards Python is that it's a language I've used a fair bit, so I've got some familiarity with it, which means when we're trying to find a developer, that'll be helpful for me to be able to ask them questions and things, and when we want to check the quality of the code, I can do some of that. Which I wouldn't be able to do nearly as well in any of the others. So that's why we're picking Python, and Python drives a lot of the other decisions as well. So there we go, that's that box covered, Python. So what's next? We've got Django. So Django is a web framework. So what is a web framework? Well, when you're writing code, you have to do quite a lot of repetitive stuff. And what a web framework does is it takes away a lot of those repetitive tasks. So we get a web framework that somebody else has written that does all the sort of logons and things that you have to do in every single web application. Also security patching, so the framework people make sure is always up to date in terms of security, which means all we've got to do is make sure we stay on the most recent versions, and we're also up to date in terms of our security. These are all open source, so we've been talking a bit about open source, and another good benefit of that for us, we get these for free. And having chosen Python, whichever framework we choose has to be written in Python, otherwise we can't use it. So really there are two main web frameworks for Python. One's Django and the other's Flask. Flask is a bit more lightweight. Django is a bit more heavyweight. We're going to use Django because it's more appropriate for an application of our size, but Django also has the better catchphrase of the two. Django, they say, pirates use Flask and the Navy uses Django, so we can't go wrong with that one. So that's back to our technology stack. So we've basically covered everything on the server side, and that's the most complicated piece. Let's have a look now at the database. A little bit more contentious, possibly, the choices here. So I'll talk about what we're going to use and why. So database has two broad technology choices. So SQL stands for Structured Query Language. It came out around the 60s, and it's a way for programmers to talk to the database, basically in English. So you can say, select last name from members database where first name equals Fred, and it'll give you a list. And you can kind of understand that stuff. It sort of sounds like English. NoSQL is a bit different. So NoSQL is really for managing unstructured data. So you've got the structured stuff there with the SQL side of things, all tables, all sort of laid out and organized, and NoSQL, you've got much more freedom to do things. You can link things around. You can do much more flexible things. NoSQL is far trendier, so most developers would want to be developing in NoSQL. It looks better on your resume, but actually the problem we're trying to solve is very structured. So all the data we want to store really lends itself to an SQL database. So that's why we're going to use that. Having decided to use that, we've got basically a choice between some very good commercial products and some equally good open source products. The commercial products are reasonably expensive. They give you a bit more in terms of add-ons and features, some report writing and things. They're pretty good. But actually there's nothing that we can't do with the open source databases. So we're going to go for open source, and the two leading ones here are MySQL and Postgres. We're going for Postgres. It tends to be the database that's most commonly chosen to work with Python. MySQL is very good as well. The slight downside with MySQL is that Oracle bought it a few years ago, so it's now sort of more proprietary, whereas Postgres is definitely more of an open product. Both very good, hard to make a bad choice in the database space. We're going for Postgres. So that's covered off most of that. So let's have a quick look at the client side. There's not a lot here. As I said before, these are both Facebook technologies. Bootstrap is the thing that lets you size the application differently on different size screens. So this is the thing where if you look on a big screen, you've got your boxes going across the side, and you look on a small screen and your boxes are going up and down. So there isn't much in the way of competition to Bootstrap, so we'll be using the most recent version of that, which is Bootstrap 4. And you've seen that in the demo already. That's what that's built with. React is for making the experience more responsive and interactive. So for doing things like sorting tables and all of that sort of stuff. We're not going to do a great deal of that, but where we do it, we'll probably use React. Of all the things there, it's the least one I'm worried about. Most of our stuff is coming from that Python code on the server. There's only a small amount happening on the client side. So that's the technology stack. So that's the basic building blocks that we're going to use to build this system. A couple more things just to go through quickly. Testing. So testing is obviously going to be a very big part of what we do. We're going to need to get a lot of people involved with helping us testing. There's going to be a lot of manual stuff, but we'll also try and automate some of the testing. So there is an approach called test-driven development, where what you do is you write your testing first before you write your code, and obviously your testing fails because you haven't got any code there, and then your goal is to kind of build that out until you pass all the tests, and then you know you've finished your code. Sounds great, never actually seen it work. I've seen people get aspects of it to work, so we'll probably go for that. We'll try and use it a bit, that sort of approach, but not extensively. It won't be our only way of doing things. that API I mentioned at the beginning for getting computers to talk to other computers, well, some of the code we write will be to test our system. So we'll be writing what they call test harnesses, so that we can run through, when we've made changes to the system, we can run through and generate a whole load of data and make sure that what spits out the other end is what we expected to see. So testing will be a fairly big part of what we're doing. Now, infrastructure. So we've finished writing our code, we've used all those tools we said we'd use, and we're ready to go and deploy it out there and have people use it. Well, it's not quite that simple. To start with, we're going to need servers to run it on. We'll need database servers and application servers, and we're going to need a network to connect these servers together. We're going to need firewalls which protect us from dodgy people on the internet coming in and getting access to things they shouldn't. We're going to need load balancers to manage it across the multiple servers, so we don't put everything on one server and have another server that's not doing anything. So we need all of that. Intrusion detection. So things to protect, anything that's anywhere near the internet needs a whole lot of protection in place. It's not a very nice place out there, so we're going to make sure we've got all of that covered, so we protect all our data. We're obviously going to have a pipe into the internet as well, so we can get to it. So we've got all of these components to put together in terms of our infrastructure. So the infrastructure is at least as complicated as the application side of things. Once we've got this, and across all of these different systems, we're going to have to patch them. So when new vulnerabilities come out, we've got to put the new software on all of these devices. We've got to upgrade them, when the hardware gets old, etc. We've got to monitor them, make sure they're working. We've got to back them up, and that in itself is pretty difficult. So there's a whole lot of stuff that has to happen with running the infrastructure for our application. And there's different ways we can do it. We can run it ourselves. So we could buy all these bits of equipment and we could set them up in a room somewhere, maybe in Canberra, and then we've got all the problems to worry about. What if we lose that building and so on? But we could run it ourselves. I don't think it's a very sensible option. We could get a data center provider to give us some space in their data center. We need things like uninterruptible power supplies, so that if the power goes off, your system still runs. You need the sprinkler systems. You need all sorts of stuff, and they would provide that for us, so we could just focus on the server bit there. Or we could use the cloud, and the cloud is the most sensible option for what we're trying to do. So we can use Microsoft's Azure, we can use Google Cloud Services, we can use Amazon's AWS systems. But we still have to look after all of these functions, even if we don't look after these devices. So all the cloud does is take away the physical part of it. We've still got all the logical part around load balancers and firewalls and all the rest of it. There is a level beyond that we can go, and that's what we're going to use for this system. And there's a company called Heroku who basically what they do is they actually use Amazon, so they use the AWS system, but they manage all of this for you. So all we have to do is we give Heroku our code and we say, can you run that for us? So they charge us a little bit more than if we did it ourselves, but a lot less than if we had to employ somebody to set all this stuff up for us. So that's it. That's what we're planning to do in terms of the sort of lower level aspects of technology. If you haven't seen the demo yet, check it out. And if you have any feedback, I'd love to hear from you. And Julian and I are looking forward to getting feedback, and we'll try and respond as quickly as we can. So thanks for listening. See you later.